Good morning friends. In the last video we have seen the earthwork estimation. In that we have seen three methods. One is mid sectional area method, second one is mean sectional area method, and third is prismoidal method. In that we have seen the formula by which we can calculate the earthwork quantity. So in today's video we are going to solve the problems based on that itself. So let's start with one problem. So let us take one problem. So in this problem they have given us the RL from a chainage of 10 to 20. So here in this table they have given the chainage, that is 10, 11, 12 up to 20th chainage they have given. So the length of chain is 30 meters. So length of chain is 30 meters. They have given from 10th to 20th chainage. The formation level at 10th chainage is 107 meters. So they have given RL of formation at the 10th chainage, it is 107 meters. All this RL of ground and RL of formation, they are in meters. Then next they have given, and the road is in downward gradient of 1 in 150 up to chainage of 14. So they have given the RL of formation at the starting chainage, that is 10th chainage. From here, that is from 11th chainage to 14th chainage, we have a downward gradient of 1 in 150, and then the gradient changes from 1 in 100 downwards. So again from 15 to 20th chainage we have downward gradient of 1 in 100. Then next is formation width of road is 10 meters. Formation width is nothing but B, that is 10 meters, and side slope of banking are 2:1. Horizontal is to vertical, that is S is to 1. So therefore S will be equal to 2. Length of chain is 30 meters. So this is the question we have. If you see the 10th chainage, means what is the distance covered. So one chain length is 30 meters. So we have covered 10 chainages. Therefore 10 multiplied by 30, if you do, you will get as 300. So here the distance will be 300 meters plus one chainage, that is 330, 360 meters, and so on till 20th chainage. So based on this data, they have asked us to draw the longitudinal section of the road and typical cross section of the road and prepare an estimate for the earthwork. This is one question. Second one is they have said us to calculate the area of side slopes. So these two things they have asked us to calculate. So let us calculate by first method, that is mid sectional area method. So they have asked us to draw the typical cross section. So what happens is that at every chainage we have to draw the cross section, but in this question they have said us to draw one typical cross section. So this is the typical cross section showing all the details. So the width of formation, that is B is equal to 10 meters. In general we have shown the depth, so depth will be variable for every chainage. Then next this is the side slope we have, which is 2:1. So this is the general cross section of road in banking. So let us calculate now. Let us start. So at the start, if you see, they have given the chainage, that is 10. Chainage is 10, 11, 12. They have given the chainages 10, 11, 12. They have given. So first we will try to calculate distance in meters. So one chain length is 30 meters. We have covered 10 chainages, means 10 multiplied by 30, it is 300. So next chainage will be plus 30, 330. Similarly 360, 390, 420, 450. You go on adding plus 30 meters till this last 20th chainage. For example, if chain length is 20 meters. So 20 multiplied by 10, we would have got this reading as 200 meters. 11th chainage means plus 20 meters. We would have added all those 20 meters. Here they have given 30 meters. We go on adding 30 meters. So in this way we will calculate the distance in meters. Next is RL of ground. So RL of ground, already this data is being given. So generally whenever they are going to do the surveying work of road, so they are going to do profile leveling as well as cross sectioning. So this is the profile leveling data what they have given. Based on that we have got the RLs. So this RL is being given. Then next is this data is already given here. You can see this data is already given here in this. Next one is RL of formation. RL of formation. So in the previous slide, if you see, they had given RL of formation as 107 meters. That is at the starting 10th chainage, RL of formation is 107 meters. Then next these RL we have to calculate based on the given data. So how do we calculate now? They have given 1 in 150. They have given the downward gradient. If you refer this, they have given the downward gradient. Now here these RLs we have to calculate for 11th, 12th, 13th, 14th changes. We have to calculate based on the data, that is downward gradient of 1 in 150. So what reading we have 107, in this we have to go on subtracting the gradient of 1 in 150. Now how to calculate this? If you see, so if you calculate, so vertical is 1. If you travel a distance of 150 meters, you will go vertically up by 1 meters. So that is what it means. They have given the gradient, gradient they have given. So our chainage is 30 meters. So what will be the vertical distance x? That has to be calculated. Once again let me repeat. So if you travel a distance of 150 meters horizontally, you will go up vertically by 1 meters. Correct? So if this is our chain length is how much? 30 meters. Chain length is 30 meters. So 10 to 11 it is 30 meters, or 300 to 330 it is 30 meters. If you travel horizontally 30 meters, what will be the distance? Whether it is upward gradient or downward gradient, this x value has to be calculated. So how to calculate? If you cross multiply, that is 30 divided by 150. If you do, you will get this as 0.2 meters. 0.2 meters. As this is a downward gradient, so we go on subtracting 0.2 from this reading. So next reading will be minus 0.2. That is 107 minus 0.2. It will be 106.8. Minus 0.2, 106.6. Minus 0.2, 106.4. Minus 0.2, 106.2. So up to the 14th chainage, they have given the downward gradient of 1 in 150. Next what they have done is they have given the gradient has changed now. Further if you see, from this 15th chainage, gradient has changed to 1 in 100. So similarly the way we have calculated here, so this horizontal distance is 100. Will go vertically up by 1 meters. So 30 is the chain length. So we have to calculate what is the x distance now. Vertically what will be the distance x? So that will be 30 divided by 100. So that will be 0.3. So as they have given downward gradient, from this reading we are going to subtract 0.3 minus 0.3. 106.2 minus 0.3, it is 105.9. Minus 0.3, we will get 105.6. Minus 0.3, 105.3. Minus 0.3, 105. Minus 0.3, 104.7. Minus 0.3, 104.4. So based on the gradient, whether it is upward gradient or downward gradient, based on that we will try to calculate this RL of formation. As this gradient is downward gradient, so therefore in this reading we have subtracted all the other readings based on the gradient. For example, if it is upward gradient, in this reading we are going to add up all the data. If it is upward, we will add. If it is downward gradient, we are going to subtract. So this row is over. Next we have to find out whether it is banking or whether it is cutting. That has to be calculated. So how do you calculate now? For example, if you plot the graph, on the x-axis we have taken the chainage. That is 10, 11, 12, 13 up to 20th chainage. This chainage data we have taken. 10, 11 up to 10. Next is in the y-axis we have taken the RL. In the y-axis. Based on this RL of ground, we have plotted the data. First RL of ground is 105. So here you can see first point is 105, 105.6. This is second reading. So based on this, what they have done, this is the ground profile. This is the actual ground profile what we have. Next is this, we will fix the, they have given the data RL of formation. Based on this, we have calculated the RL of formation. So this is the formation line. This is the formation line. So if you see, this is the ground, actual ground profile what we have. Then next, this is the actual, this is ground line, this is the formation line. So this is the, for example, if this is the road top level, so what happens is this much data, this much, what you can say, this much of filling has to be done now. So this is our actual road top level, this is the ground profile. So here this gap what you are seeing here, we have to fill the road, and up to this level it has to be brought now. So how much filling has to be done, that has to be seen. So if you see in this case, our formation level is above the ground level, above the ground level. So therefore what happens is that, so everywhere we have to do filling itself, everywhere we have to do filling itself. So there is no cutting here. So therefore what all quantities we get, it is in banking itself. We are not going to get cutting. Why? Because formation line is above the road level. So now how to calculate what is the difference now? This difference has to be calculated at 10th chainage. What is the difference? If you see, this RL is 107, 107 RL we have. Next is 105. 107 minus 105, if you do, you will get this depth. 107 minus 105, it will be 2 meters. It will be 2 meters. Correct? 107 minus 105, you will get depth as 2 meters. Similarly, we go on calculating all these depths. Next is 106.8 minus 105.6. It will be 1.2. 106.6 minus 105. It will be 1.16. Similarly, we go on calculating all this height of banking. For example, if it is cutting, we will get the negative answer. So sometimes what happens is that we will not draw this longitudinal section. Directly if you are calculating, so how will come to know whether it is banking or cutting? So when you are going to subtract this RL of formation minus RL of ground, if you are getting positive answer means it is banking. If you are getting negative answer means it is cutting. Based on that you can identify, right? In the question they had asked us to plot the longitudinal profile. So this is the longitudinal profile showing the RL of ground and RL of formation. Then next they had said us to calculate, they had said us to show the typical cross section. This we have shown. Next is they have said us to calculate the quantity of earthwork. So this is the graph what we have drawn. Then next we'll go and we'll calculate the earthwork quantity by mid sectional area method. So let me revise what we do here in this case. In this mid sectional area method, we are going to take the mean depth. At section 1 we will have depth d1. At section 2 we will have depth d2. We will take average of two depths, that is d1 plus d2 divided by 2. This mean depth we are going to calculate. Based on this we are going to calculate the quantity. So once again let me tell you how to calculate the quantity. We will take the cross sectional area multiplied by length. Area multiplied by length, we are going to get the volume, that is area multiplied by length, we are going to get the volume. So if you see this table is self-explanatory. If you remember this top line, it is more than sufficient for you to solve this problem completely. Only these things you have to remember what we are doing. If you remember these things, these formulas, whole table can be solved very easily. This table is self-explanatory. So let me explain now. This first column is station or chainage. So they have given the chainage 10, 11, 12 up to the 20th chainage. Same way I have written it vertically. Next is length. So we have written length. So chainage is 10th chainage. Length of chain is 30 meters. 10 multiplied by 30, it is 300. So next chainage means plus 30. 330 plus 30. We go on adding. We will get the total length up to 600 meters. Next, this RL of ground. This data is already given to us. Then next is RL of formation. Already we have calculated this based on the gradient. So sometimes what happens is that in the question paper they will tell you to plot the longitudinal profile. So if it is not asked directly within this table, you can calculate within this table. So this RL was given to us. So next they had given the downward gradient. Directly based on that gradient you can calculate these values. You need not draw the profile, longitudinal profile. Then next is depth. Depth D how we have calculated 107 minus 105. We will get 2 meters. Similarly 106.8 minus 105.6, it is 101.2. So similarly we go on calculating this column. If you are getting positive answers, that means it is in banking. If you are getting negative answer, that means it is cutting. Then next is we have to calculate the mean depth. This is the depth D. Next is we will calculate the mean depth. How do you calculate the mean depth? So at the starting section we cannot have the depth. So therefore this row will be blank. Mean depth means we require two depths, right? So this is starting first D1, this is D2. So 2 plus 1.2 divided by 2, it will be 1.6. Similarly 1.2 plus 1.6 divided by 2, it is 1.18. Next is 1.16 plus 0.5 divided by 2, you will get 0.83. So similarly this you will get this. Similarly for this you will get this. Similarly for this you will get this. Similarly for this you will get this. You go on adding this, you will get this depth. So we have to take the average depth. So this column is over now. Next is area of the central portion, that is area of the central rectangular portion. Width is B, depth is dm. So B is nothing but already in the question they have given formation width, that is 10 meters. 10 multiplied by this dm has to be done. So 10 multiplied by 1.6. B is 10 meters. So therefore we will multiply 10 by 1.6. It will be 16. 10 multiplied by 1.18. It is 11.8. So you go on multiplying 10 to these values. You will get this answer. 0.64 multiplied by 10. It will be 6.4. So you go on multiplying it by 10. You will get this column. So you have to multiply it by B. You will get the column. Next is S into dm square. S into dm square. So if you read the question, they have given side slope as 2:1. 2:1 they have given, right? So they have given 2:1. So 2:1 is nothing but S is to 1. So therefore S will be equal to 2. S will be equal to 2. So value of S is how much? 2. So 2 multiplied by dm square. Dm is nothing but the mean depth. So 2 multiplied by 1.6 square, you will get answer as 5.12. Next is 2 multiplied by 1.18 square, you will get this answer as 2.78. So 2 multiplied by this, S is nothing but 2, dm is nothing but this column. So 2 multiplied by 0.83 square, you will get answer as 1.38. You go on calculating this column. This will be over. Then next is total sectional area. How do you calculate total sectional area? Area of the rectangular portion plus area of the two triangles. If you are going to add up, you will get the total sectional area. Already I had explained this in the earlier video. You can refer that. B into dm plus S into dm square. So this column and this column, if you are going to add, you will get this total sectional area, that is 16 plus 5.12, you will get answer as 21.2. 11.8 plus 2.78, you will get answer as 14.58. You go on adding these two values, you will get this answer. You go on adding this, you will get the answer. Similarly, you can calculate this column. Then next is length between the stations. So you can see here 300, 330. So length between these two stations is 30 meters. We have written here. So 330, 360. Distance is 30 meters. We have got 30 meters. So chain length is 30 meters. At every chainage we have noted down the reading. So therefore this column will be 30 meters. Next is we have to calculate the quantity. We'll be having two columns. One is banking and one is cutting. So how you will come to know? If the depth is positive, we will get banking. So here in this column, if you see, all the values are positive. So therefore what answer we are going to get, everything will be positive, that means it is in banking itself. If you are getting negative depth means, for example, if this is negative now, so this answer we would have written in this column, correct? So let's see this problem. So now how to calculate this quantity, that is cross sectional area multiplied by length. Cross sectional area is how much? B into dm plus s into dm square multiplied by length. So this column multiplied by this, if you do, you will get this banking value, correct? So 21.12 multiplied by 30, you will get 633.6. 14.58 multiplied by 30, you will get 437.54. 9.68 multiplied by 30, you will get 290.33. You go on multiplying this column and this column, you will get this. So similarly you can calculate for all this column, correct? So we will get the banking quantity. At the end we have to sum up. You do the sum of these things. You sum of these quantities, you will get the total quantity, that is 3513.76. Unit is cubic meters. As we have calculated the volume, that is area multiplied by length. So unit is cubic meters. So 3513.76 cubic meter is the answer. So this we have calculated by mid-sectional area method. Next is we will try to calculate the area of side slopes. Area of the side slopes. So this also we will try to calculate in tabular form itself. So station and chainage, already we know this, we can write it down, already we have written in the previous table. This depth also we know, already we have written it in the previous table. Then next is mean depth also we know, already we have written this in the previous table. So only these three columns will be extra. Next is sloping breadth. So area of, we have to calculate the area. Area is nothing but sloping breadth multiplied by length. If you multiply, you will get the area of the side slopes. Already in the last class we have seen what is the sloping breadth. How to calculate the sloping breadth? D into square root of s square plus 1. This is nothing but sloping breadth multiplied by length. If you do, you will get the area, that is L multiplied by D into square root of s square plus 1. You will get the area of one side slopes. As we have two sides, so we have to multiply it by 2. If in detail if you want to see, you can refer the previous video. Multiply by 2, you will get the two side slopes. So this much if you remember, this easily you can calculate these values. So D is nothing but the mean depth. Already we have calculated the mean depth here. Next is S. S is equal to 2 we know. 2 square plus 1. Square root of that multiplied by 1.6. If you do, you will get 3.58. 2 square is nothing but 4 plus 1, 5. Square root of 5 multiplied by 1.18, you will get answer as 2.64. Similarly, you go on calculating this column. Next is length. Length also we know, chain length is 30 meters. So this is 30. Next is this area of the side slopes. That is L multiplied by D into square root of s square plus 1. This L multiplied by D into square root of s square plus 1. So this is for one side. We have two sides, therefore it is multiplied by 2. Therefore it is multiplied by 2. This column multiplied by this column multiplied by 2, if you do, you will get this column, right? So therefore 2 multiplied by 3.58 multiplied by 30, you will get answer as 214.66. Next is 2 multiplied by 2.64 multiplied by 30, you will get this answer as 158.31. Similarly, you go on adding, you go on calculating, you will get these values. Finally, you sum up these values. You sum up these values, you will get area as 1297.33 square meters. So this is the quantities, these are the quantities we have. If you multiply it by rate, you will get the cost of the earthwork and cost of the sloping or pitching, what we do, stone pitching and all. If you want to do, this is the area of stone pitching that has to be done. If you multiply with this quantity, you will get the final cost. So we have seen it, same problem we will try to calculate it by mean sectional area method. We will try to calculate by mean sectional area method. So once again let me revise. In the previous tabular column we have calculated by mid sectional area method. That means we used to take average depth, that is D1 plus D2 divided by 2. We used to take the mean depth. But here the name tells mean sectional area method. So in this case we are going to take the mean area, right? So let us see this table now. So again, the station and chainage, this will remain same, length will remain same, RL of formation will remain same, RL of ground and RL of formation, and depth will remain same. If you see if you compare it with the previous tabular column, so as it was previously, it was mid sectional area method, so we used to calculate the mean depth. So here we had one additional column wherein we used to do the mean depth. This is not the mean depth method, this is mean sectional area method, so that gets eliminated. Next is area of the central portion. How do you calculate? B into D. B is nothing but formation width, that is 10 meters. So 10 multiplied by D, 10 multiplied by 2 is 20, 10 multiplied by 1.2 it is 12, 10 multiplied by 1.6 it is 11.6. Similarly, we go on calculating this column. Next is area of two triangular portion, that is S into D square. S is equal to 2, already we know, multiplied by D square. 2 multiplied by 2 square, 4, 2 square is 4, multiplied by 2 is nothing but 8. Next is 2 multiplied by 1.2 square. So already here in this tabular column itself, I have written the formula what we are doing. If you remember this much, easily we will be able to calculate this in this tabular form. It's very easy. So this we go on calculating this column. Next is BD plus SD square, that is here we have BD plus SD square. This column and this column, this column and this column has to be added, so as to get this next column, that is 20 plus 8, that is 28. 12 plus 2.88, that is 14.88. So you go on adding these two columns, you will get this column values. Then next is mean sectional area. So for the starting chainage, we cannot calculate the mean, only one area we had, so we require two areas, so as to calculate the mean. So 28 plus 14.88 divided by 2, it will be 21.44. 14.88 plus 14.29 divided by 2, it will be 14.59. 14.29 plus 5.5 divided by 2, it is 9.9. Similarly, you go on calculating the mean area. Next is, this is the length between the station, this will remain same, that is 30 meters. Next column is quantity, banking or cutting. So as depth is positive, we will get banking quantity itself. So here we are going to write. So how to calculate quantity? BD plus SD square multiplied by L, that is this mean sectional area. What mean we have calculated, this has to be multiplied by L. So that is 21.44 multiplied by 30. You will get 643.2. Next is 14.59 multiplied by 30. You will get 437.57. Similarly, you go on multiplying, you will get this column. If you add up this column at the end, you will get answer as 3575.60 cubic meters. If you compare this value with mid sectional area method, there will be slight variations. Calculation of side slopes will remain same. There is no change in that. Only so as to calculate this earthwork quantity, there is the change. So let me tell you now what we have done in this video. Till now we have solved one problem by mid sectional area method and mean sectional area method. So what we have done, we have calculated the quantity of earthwork and quantity of the area of the side slopes by these two methods.